Hi class, let's take a look at example 3, actually problem 3. Now problem 3 has a minor problem on its own, and notice that it says that basically some unknown is less than a negative. And because you have the values of less than a negative, and this is in fact an absolute value, this is automatic a no solution. So no solution, this is one of those empty sets. And here's the basic idea. When we're solving inequalities, in this case absolute value inequalities, we're looking at distances. The minimum that a value can be in terms of a distance is 0. So if we look at the formulas given in this part of the handout, when you're looking at technically formula B, you're assuming this is a non-zero value, meaning that from a basic point, your distance is going to be, well, this length. But you cannot have a negative value since distances cannot be less than a negative. So this one is a little bit tricky. For the problem being, because it says less than an actual negative value, in this case is a no solution. If it said greater than a negative value, then in that case it would be all real numbers, since technically all distances would be greater than a negative value. But for this one, less than means automatic no solution. Let's take a look at B. And then B is actually set up okay because you have an unknown, distance of an unknown equal to 1. So in this case, we're going to actually solve the following two equations. So we're looking at 2x minus 4 is equal to negative 1, or 2x minus 4 is equal to 1. And then we're solving each of these. So we would add the 4 and the 4, add the 4 and the 4. So this is going to give us 2x is equal to 3, or 2x is equal to 5. And then at this point, we divide by 2, divide by 2. So we end up with x is equal to 3 halves, or x is equal to 5 halves. Also, keep in mind that this is in fact an equation, so you would just have the points. The problem they're just saying to solve. So let me just rewrite it as the solution. X is equal to 3 halves, or x is equal to 5 halves. Let me put the set, because I don't think we've done a set that only contains two values, or I don't remember. So in this case, it'll be 3 halves, comma, 5 halves, and that would be fine. They're not asking for any specific way to express a solution. All they mention is to solve. So in this case, this would have been sufficient to express the 3 halves and the 2 halves as the solution. That's it for part B. Now let's take a look at part C. And in part C, it's one of those greater than a number. Because it says a positive value, we are going to use the formula and technically solve two inequalities. One of them is going to say x is less than negative p, and the other one, x is greater than p. I'm rewriting this one because the way that the author provided it here is a little bit confusing. So in any case, we're going to end up solving for this one. So we're going to solve 2x minus 4, it's less than or equal to negative 1, or 2x minus 4, it's greater than or equal to 1. And notice that it's basically all these steps here. But let me just redo them again. So plus 4, plus 4, plus 4, plus 4. So we would end up with 2x less than or equal to 3. Or 2x greater than or equal to 5. And then we would simply carry on the division of the 2's. So we would end up with x is less than or equal to 3/2, or x is greater than or equal to 5/2. And let me just rewrite it as the solution. X is less than or equal to 3/2, or x is greater than or equal to 5/2. Now, they only want the solution, so let me add the graph so that we're clear on the difference between B and C. And the graph, not to scale, would look something like this. So this is 0. I'll just put that this is 3/2 and that would be 5/2. I'm running out of space here, so this is just so that you see the difference. When we do the partition of the two unknowns, because it's a distance greater, we're looking from some sort of a center to the left and to the right, which gives us the following. And in this case, it's a greater than or equal. So technically, you're going to include the boundaries, which is technically your 3/2 from the equation. Notice that first we looked at when is this distance equal to 1 of the unknown. That happens at 3/2 or 5/2. And then for C, it's greater. So you end up with every value to the right and every value to the left of the boundaries. Because this is greater than or equal, you would actually include the edges of the inequality. And that would be the solution for C. Once again, they're not asking, give me just a second, it's too thick. They're not asking for anything else other than to solve it. But I just wanted to put in perspective the difference between the equation and any of the inequalities. Also, we have to be very careful with how some of these inequalities are given, and you have to keep into account that an unknown, if it's an absolute value, cannot be less than a negative. It's always greater than 0. So that's it for problem 3. I'll put the other problem on a different video.